What if I told you that every minute, over 4 million YouTube videos are viewed, 600,000 photos are shared on Instagram, and Netflix users stream hundreds of thousands of hours of video content? That's mind-blowing, right? But these numbers are just the beginning. We'll dive into how massive the internet truly is, from data traffic, number of websites, users around the world, to what the future holds. By the end, you'll see the internet in a way you've never imagined. If you've ever wondered what powers your daily scroll, stream, or send, this is for you. Because we often think of the internet as a tool. Search, chat, watch videos. But behind that tool lies an immense, constantly growing infrastructure, overwhelming volumes of data, and an ever-expanding user base. And that's not just trivia. It impacts privacy, speed, security, and even the future of jobs and innovation. As of mid-2025, there are over 5.4 billion people using the internet globally. That's nearly 67% of the world's population. But growth has not been linear. In 2005, there were just over a billion users. In 20 years, we've multiplied that by 5. That means millions more people are coming online every year in Asia, Africa, Latin America. More users mean more data, more traffic. Everything scales up. How many websites are there? Estimates put the total number of websites at around 1.3 billion, though only about 200 to 250 million are active or regularly maintained. Google alone handles over 100,000 searches per second, which is roughly 8.6 billion searches per day. If each search took just 5 seconds to load, that's hours of cumulative waiting time globally every single day. When you stream a show, post a photo, or send a message, those aren't just isolated actions. They connect through servers, data networks, cloud providers, all constantly running. How much data moves every day? According to recent reports, the world's internet traffic is now over 330 exabytes per month. That's more than 10 exabytes per day in many months. To put it in perspective, 1 exabyte equals 1 billion gigabytes. If you tried to download 1 exabyte on a 100 bits per second connection, it would take you over 100 years. Also, video content dominates. Services like Netflix and YouTube account for a large majority of global downstream traffic, over 60% in many developed countries. And with mobile devices, smart TVs, IoT devices, even more traffic is being generated outside traditional computers. The internet isn't just virtual, it has a physical backbone. Undersea cables, data centers, fiber networks, these make up the skeleton of the web. There are over 400 submarine cables around the globe carrying over 99% of international data. Data centers too, huge buildings consuming megawatts of power, cooling systems, backup generators. They store and serve your messages, photos, and video content. Cloud providers like AWS, Google Cloud, and Microsoft Azure handle trillions of requests every day. These infrastructures are invisible to most users, but absolutely essential. Internet growth isn't slowing down. With more of the world's population coming online, 5G or 6G rolling out, IoT expanding, and emerging technologies like VR, AR, and even satellite internet like Starlink, demand will skyrocket. One interesting projection: global internet traffic could more than double in the next 5 years. But with that comes challenges: bandwidth constraints, latency issues, privacy and security needs, and sustainable energy usage. To wrap up, when we talk about the internet, it's not just what's on your screen. It's billions of people, millions of websites, exabytes of data, and physical infrastructure across continents, all working together every second. It's vast, it's powerful, and it's still growing. If you found this enlightening, make sure to smash the like button, subscribe for more deep dives into tech, and leave a comment. What surprised you most from today's video? Is it the data traffic, the number of users, or how fast things are expanding? Thanks for watching, and I'll see you in the next one where we explore how AI models are trained on all this data.